Good afternoon. Welcome to Math with Business Applications. I'm Amy Fuchsteiner, your instructor, and we're about to begin our last unit for this term. It is chapter 12 in your textbook. We're going to be doing annuities, sinking funds, and problems with amortizations. This is unit 8, and our first section is the future value of an ordinary annuity. I will mention that you will possibly want the tables I have in your assignment module. There is a folder, and in that folder, the first thing you should see is a print off of the partial tables, a print off of the partial tables you will need for this particular unit, this particular chapter. On the back side, I also put together a decision tree. You'll see that in the last presentation that we go through here. It won't be in today's. It'll be in the very last one. So this is chapter 12, section 1. Our goals for this section are as follows. We want you to be able to identify and work with an ordinary annuity. There are several in this section. We are going to be specifically targeting in on an ordinary annuity. We want to use a manual calculation to explain how an ordinary annuity works. And then we're going to show you how to use the future value table to calculate the future value of that annuity. So how much will it be worth in 5 years, in 10 years, etc. That means we need all of the same pieces that we did for last chapter. You will need to be able to find the interest rate per period, the number of compounding periods, and in this section, we'll be able to identify the payment amount, not the lump sum, but rather the payments. We're going to use the future value formula for an annuity to calculate the future value of that annuity. Again, being able to identify the different parts of that formula and use a scientific calculator to determine the future value. As always, we want you to be able to separate the amount of money that's actually invested from the interest earned on the account and the future value of that annuity. So we're going to start with the different types of annuities. An annuity is a payment or receipt of equal amounts of money in equal amounts of time that are specified. So these are regular payments. Annuities are monthly savings accounts or monthly bills that you pay. There's money either put into a savings account or used to pay down a debt. They are given in a very specific amount of time, usually monthly, sometimes annually. We'll also be dealing with some that are semi-annually and quarterly, maybe even weekly. And they'll be for a very specific amount of time, 5 years, 4 years, a year and a half, whatever. So it's a specific schedule for a defined or definite period of time. This is, we're going to be dealing specifically with simple annuities, and simple annuities are annuities where the compounding periods and the number of times the payments are made match up. So we're going to have them match because the math, if they don't, is very complicated and we're just beginning. So we want you to be able to have the annuity compounded monthly, and that would mean monthly payments. If you're paying in quarterly, then that would mean the compounding has to be done quarterly. This is known as a simple annuity when the payment timing and the compounding schedule match up. All right? When they don't match up, that's called a complex annuity. In a complex annuity, the compounding periods and the payments don't coincide. So it might be compounding annually, but you're paying monthly. And if you remember partial payments, those are rough. Those are rough. Annuities certain are annuities where you specify the number of periods. So the time doesn't matter. We're not going to say 4 years. We're going to say rather, we're going to make 4 payments. That's an annuity certain. And then some annuities are contingent. Now, contingent annuities are essentially based on an uncertain time period. Uncertain meaning there's no guarantee. So a contingent annuity might be on somebody's life. Y'all might remember, what was the guy, Ed McMahon and the sweepstakes, right? And you could get $5,000 a week for the rest of your life. That would be a contingent annuity because it's contingent on your death. Not that that's a happy thing, but they'll pay you as long as you are alive. So there's a defined time, but it's an uncertain time period because, we don't know when we're going to die. All right. There are two types of annuity payments. The future value of an annuity is sometimes also called the amount of the annuity, is based on part in when that annuity is paid in or received. So you don't just get to pay in any time during the month. There are two specific types. The first type is an ordinary annuity. And an ordinary, I'm having trouble speaking. An ordinary annuity occurs when that annuity is paid into or the amount of annuity is received at the very end of the month. So, well, I shouldn't say month, the end of the time period. So an ordinary annuity occurs at the end of the time period. So it's the end of the year or the end of the month or the end of the quarter. That's an ordinary annuity. The other one is an annuity due, and an annuity due is paid at the beginning of each period. So the beginning of the year, the beginning of the month, the beginning of the quarter. Everything that we do in this class is just going to deal with the ordinary annuity. We are not going to be doing annuity due. Some things had to get cut out. Annuity due is the one thing that got cut out. All right. So if you're doing homework and you come across one you're just not getting, and it says at the beginning of the period, that's an annuity due. Flag it. Send me an email. You should not be getting problems like that. All right. Specifically in 12.1, we are doing ordinary annuities. And as you recall, ordinary annuities are payments or deposits that occur at the end of the time period. For deposit, that would mean there is zero interest earned that first period. And the last payment is not going to make any interest at all. So these are two key ideas in an ordinary annuity, that the payments or deposits occur at the end of the month and that will have consequences to the amount of interest that is earned. For example, there is a calendar here. Yes, it's January 2013, but that's just what the image gave me. All right, so the idea here is that you open that annuity at the very beginning. So you open that annuity at the beginning of the month. Maybe it's not the beginning of the month. Maybe you open it on the 4th, but still it's opened at some point. So technically, as soon as that annuity is opened, your interest begins. But since you don't pay into the annuity until January 31st, you make no money that first month. Your payment into the annuity is not made until the end of the month, even though you may have opened it at some other time. So it is not always considered worth your while to open an annuity in the beginning and then not make a payment. You tend to want to open one right at the end, so your money's working for you right away. All right. That being said, here's how an ordinary annuity works. We're going to do a manual calculation of an ordinary annuity. Here's the information we have. The bank is paying 8% interest, and it's going to compound that interest annually. We're going to find the future value of $1,000 deposited at the end of every year for 3 years, right? So when we open this annuity at the beginning of year 1, we open it with $0 in it. $0 in it. Since we're only compounding annually, a whole year goes by. And during that year, since there's zero monies in the account, we have $0 at 8% interest for 1 year gives us $0. And then on December 31st, the end of the first year, we make that payment of $1,000. So at the end of the first period, we've earned $0 in interest, but we've put $1,000 into the account, right? We then begin the second period with that $1,000. So there's $1,000 in the account. And since the interest is compounded annually, we wait an entire year earning 8% interest on that $1,000. and that puts $80 into the account. So at the end of the second term, the second year, we put $80 into the account, and we make a second payment of $1,000. So now, at the end of the second period, there is $2,080 into that account. The $2,000 are the two $1,000 payments we've made. The $80 is the interest that was earned in the second year. That means we can begin the third year with $2,080. That entire year, we're earning 8% interest on that $2,080, which is $166.40. We add that interest back in at the end of year 3, and we also add in another $1,000 payment. This gives us a total of $3,246.40. So the future value of this account would be the $3,246.40. Now, hopefully that gives you a better idea of how this works. And you can see that the interest is consistently being added, but because we're making payments into the account, the interest is going to, well, double and triple. It's going to start adding up, right? Quite a bit. So other than this manual calculation, where we keep having to calculate the interest and put it back and calculate the interest and put it back, there's got to be a faster way. Well, there are two faster ways. The first faster way is a table, much like we did for Chapter 11. That's coming back. And then the second way is a formula. We're going to start out today's presentation with the table. The table is not the same table. This is a different table. This table is 12-1. It is the future value or the amount of an ordinary annuity of $1. So this is all done as if you would do $1. Once again, I would remind you that there is a print version of this available on Blackboard in your assignment module, and most of the homework problems that use the table tell you exactly which table to use when you're doing the problem in WebAssign, and you just need to click on the link that says 12-1. Okay? It's worth noticing that all of these start with 100%. All of them start with 1 and go up from there. All right? The actual table in your textbook, or the actual 12-1 table in WebAssign, goes up to, I want to say it's 36 periods and 15-ish percent, I want to say 14 or 15%. So there's a lot more than this here. There's a lot more than this here, but this is just to give you an idea and have you some paper copy to deal with as you're going. All right? So an ordinary annuity. How do we find one using the table? The steps are almost essentially the same as before. For calculating the future value of an ordinary annuity using the table, the first step is to calculate the interest rate per period. We did this last chapter. You want to find the nominal or annual interest rate and divide it by the number of compounding periods in a year. Then you want to find the number of compounding periods total, your N. And to find the number of compounding periods total, you need to know how many compounding periods there are in 1 year, and then you have to multiply that by the number of years the annuity runs. Once you have that, you're going to locate the table factor in the ordinary annuity future value table. That is table 12-1. If you have a physical copy of the textbook, I believe it's pages 372 and 373. And once again, there is a printable version, although it is abbreviated, in the assignment module. Once you have that table factor, all you need to do is multiply the payment amount, not the principal, that should read payment amount, by the future value annuity table factor. That will give you the future value. So here we go. For 12-1, here is a problem to try. Carl opens up an annuity paying 8% interest, compounded annually. He deposits $1,000 at the end of every year for 3 years. So this is essentially the problem we just did. What is the future value of Carl's annuity at the end of those years? So we're going to find the I value, the interest rate per period. It's an 8% stated rate. We're compounding annually, so that's 1. 8% divided by 1 gives us an 8% that we're looking for on the table. Our total number of compounds is once a year for 3 years. So if we look at the table and we identify the table factor for 8% and 3 periods. So on the table, I'm going to go down the row, the column, that is 8%, and I'm going to cross for 3 periods, and I have a table factor there of 3.24640. 3.24640. So I'm going to take the amount of Carl's deposit payment, which is $1,000, and I'm going to multiply that by the 3.24640 to get $3,246.40. Okay, so the future value of this annuity is $3,246.40. Now, the question is, how much did Carl actually invest in this, and how much interest did he earn? Remember, we said one of the goals of this class is that we want you to be able to identify Carl's investment versus the interest versus the future value, the 3 parts of this annuity. So Carl was investing $1,000. He was investing $1,000 once a year for 3 years. So Carl has put in $3,000. Carl's hard-earned money has been $3,000. How much interest did Carl earn? Well, the interest would be that future value of the $3,246.40 minus the amount of Carl's investment, which we know was $3,000. So the interest in this annuity is $246.40. Second example. Let's make sure we got it. Jess is opening an annuity earning 4% interest compounded quarterly. She's going to deposit $300 at the end of every period for 6 years. What is the future value of Jess's annuity? Okay, couple of things. We want to make sure that it's an ordinary annuity, which means it should be happening at the end, and it does say at the end. We know it's a 4% interest rate compounded quarterly. Quarterly is 4 times a year, and we know that Jess is going to do this for 6 years. So we need to find our I and our N, same as last time. Interest rate is 4%. We're going to divide that by 4 periods in a year so that we see 1% interest per period. Total number of compounds is 4 times a year for 6 years, or 24. On our table then, we're going to look up 1% for 24 periods. Now, this table that you see here is all 36 of the periods. So this is the full 12-1 table for the up to 8%. It doesn't show the other side of the page, which is, I think, 9% through like 14 or 15%. All right, but if we go down the column that is 1% and we come across at 24 periods, we see a table factor there of 26.97346. This gives us our multiplier. Now, I'm going to say this, and hopefully it's not a waste of time for you, but look at the total number of periods. Total number of periods is 24. Look at the table factor. That's 26.93746. The number in the table factor for annuities should be more than the number of periods, because we want there to be more money than if just put $300 away 24 times. We want there to be more than that. If Jess just puts $24 or $300 away each of those 24 times, if she doesn't earn any interest, she's just going to have that amount of money. So we want her total value to be worth more than the 24 times she put money away. Hopefully, when you look at that, you see that that number, 26.93 or 97346, has to be more than the 24 in order to earn interest, right? So, to find the future value, we're going to take that table factor of 26.97346 and multiply it by 300. This gives us $8,092.04. So that should be how much Jess has in this account after 6 years, $8,092.04. Now, how much has Jessica invested and how much interest did she earn? Well, we know that Jess put in $300. She put in $300 4 times a year for 6 years, or 24 times. So when we multiply that out, we can see that Jess has invested $7,200. That's how much Jess put in. The value of that account at the end was actually $8,092.04. So that's more than Jess put in. The interest then is the difference between the future value in that account, the $8,092.04, and the amount of Jess's investment, or $7,200. That's $892.04. So the interest here is $892.04. Now, I'm not going to add it in here. This is just a little golden nugget that I'm putting in. I'm not testing on this. But if you take that $892.04 and you divide it by Jess's payment of $300, tell me what you get. As I have done in the past, there is a practice table here. I am not necessarily going to go through, well, yeah, I guess I am. All right. So with this practice table, it's just an opportunity for you to grab your calculator and check your skills. Make sure that you can find things on the table here. So we've got a $2,500 annuity payment semi-annually for 5 years. It is at 10% interest compounded semi-annually. Notice that the semi-annually here and here match. The semi-annually frequency and the semi-annually compounded. Those are the two that are meant to match. So I need to find my I. Oh, table coming in. All right, so my I value would be the 10% divided by 2, because I'm compounding semi-annually. That gets me 5%. Number of compounds would be 5 years and twice a year, so that's going to be 10. Then I'm going to go to table 12-1 and look up 5% for 10 periods. So we're going to find 5% column, and then we're going to go across the 10 periods to get a table factor of 12.57789. The future value of this account will be that $2,500 multiplied by the 12.57789. That will be the future value of this account. All right? I'm going to ask you to take a minute and do the next 2 problems. I'm just going to click through them. So if you would like, you can pause now, and I'll let you know when to rejoin in a minute here. All right, now that was the first way, that was the table. The second thing we want you to be able to do is the ordinary annuity formula. Now, the ordinary annuity formula is no joke. This is not a joke formula. It is a little bit of a calculator stressor. If you're using your computer or your cell phone as your calculator, you're going to want to know how to switch it onto scientific mode. For me, that means rather than holding my phone the long way, I need to flip it this way, and then all of a sudden I'll have powers and parentheses and all kinds of other things. So whichever one you're using as you go through this, just be aware you will need the scientific functions, whether that's a scientific calculator or whether that means you're switching your app on your phone or your computer to the scientific version. All right, so the ordinary annuity formula looks like this. It says that the future value is equal to the payment times, and then big parentheses. In the numerator, you have this little thing that is 1 plus I to the nth minus 1. And then in the denominator, you have an I again. All of the parts here are very similar. The FV stands for future value. This is the total amount of money that you're trying to build to. The payment is the regular payment amount. You know this amount. When you use the ordinary annuity formula, you know the amount of payment. All right, you know how much you have to put away each month, or you know the amount of money you're receiving each month. The I is the interest per period, the same as we found before, but you want to make sure for the formulas that you're putting it in as a decimal. The N is the total number of compounds, all right? N is your total number of compounds. So we want you to be able to use your calculator to do this. Let's just do it. Okay. Now, if you need calculator help, please be sure to ask myself, Embedded Support, or the Math Center. Get to somebody who knows how to use a calculator. It's really hard to guess and check these. When you do annuity, it's really hard to guess them. So it's best that you know how to use a calculator. And for many of you, it'll be best if you go through the problem twice, sometimes 3 times, to make sure you're getting the right answer. All right? So when you go to use your calculator, make sure you know what your variables are. From your problem, identify your payment, your rate, your compounds total, the amount of time. Make sure you have your I and your N pre-calculated. And then on your calculator, know those symbols. ANS is your last calculation. Know how to get to your powers. Know how to raise it to a power. That's either going to be the little caret key or chevron key, some people call it, or some calculators have a Y to the X key. Now, some of you, if you know how to use your memory and your recall on your calculator, those are very helpful as well, right? Lastly, use your order of operations. So when you see the formula, you're going to begin by adding what's in the parentheses first, the 1 plus I, or the I plus 1. You then want to raise that to the power. Depending upon order, you're either going to subtract 1 from it, or subtract that from 1. And then you want to divide that answer by I. Once you know what that is, you're going to multiply by the payment. Walking through it like this doesn't help as much as actually doing a problem. So here we go. To save for a new car, Amy puts $200 into an ordinary annuity every month for 4 years. The annuity earns 9% interest compounded monthly. 2 things. Notice I've stated it's an ordinary annuity. The payment amount is $200. I know it's monthly, and that monthly matches with the compounding monthly. I'm doing it for 4 years because it's Amy, so it's me. And I know that the interest rate is 9%. So my I and N are the 2 things I'm going to find first. So the I value would be the 9% divided by 12. Notice I'm changing my percent to a decimal, 0.09, because I'm putting it into a calculation, right? So because I'm putting it into a formula, I want to convert my 9% to 0.09 as a decimal. This makes my I value 0.0075. N is the total number of compounds, periods. And so that'll be 12 times 4, which is 48. The regular payment that Amy has to make is $200. So the formula is the future value is equal to the payment times 1 plus I to the N minus 1, all of that over I. I'm going to do this piece by piece. 1 plus I would be 1 plus 0.0075 to the 48th power minus 1 all over 0.0075. Once I have that number, I'm going to multiply it by 200. I'm going to do them piece by piece. First, the parentheses, 1 plus 0.0075 to the 48th power. So that's going to give me 1.431405333, from which I have to take away 1 to get 0.431405333. I now need to divide that by 0.0075. Because it's in those bricked parentheses, or those squared off brackets, I'm going to do that division first to get 200 times 57.52071107. When I multiply that out by the $200, I get 11,504.14222. This is the amount of money that will be the future value of this account. So Amy has been able to squirrel away $11,504.14. That will be the future value of that account. However, how much has Amy really invested? How much of Amy's hard-earned money is in that $11,504.14? And how much of that account is interest, right? So Amy's putting away $200 12 times a year for 4 years. When we multiply that out, 200 by 12 by 4, we get $9,600. So Amy has actually invested $9,600 in this account, $9,600. In the account is $11,504.14. So the interest is the difference between the future value of that account and the amount that Amy has invested, the $9,600. This is just a subtraction problem to find that interest. So we're going to take the $11,504.14 and we're going to subtract the $9,600 to get $1,904.14. And that's how much interest Amy earned on this annuity. That's not bad. I mean, yeah, it took 4 years to get there, but that's almost $2,000 she didn't have to put in herself. Okay? Let's try second problem. Steve is going to open an ordinary annuity to save for retirement. Each week, he is able to put $50 into an account, earning 1.3% interest compounding weekly. What will the annuity be worth in 30 years? So we have a low amount here of $50. We're compounding weekly. That's 52 times in a year because there are 52 weeks in a year. But the best thing we got going for us is 30 years till retirement. Now, I'm not going to work until I'm 80, so that's not going to work for me, but might work for some of you. Here we go. We're going to find the I value. Ooh, that should be 0.013 or 1.3% divided by 52 weeks. Let's see. Yeah, there we go. Let's get a pen here. Let's change that to a 3. We'll fix it later. There's always got to be a small mistake in these, right? So we've got 1.3% converted to a decimal, 0.013, divided by 52, 0.00025. I feel like I might have an extra 0 in there. So 0.013 divided by 52. Nope, 3 zeros, 0.00025. All right, total number of compounds. Well, 52 times a year for 30 years gives me 1,560 compounds. The regular payment amount here is $50. It's just $50, starting out low because we got 30 years to earn. Let's see, $50 a week. We're using the formula because that interest amount is not a good number and 52 is not something that we want to do. So we're going to take the future value formula for an ordinary annuity, which is the payment times square brackets 1 plus I to the nth minus 1 over I. Substituting in what we know, the I, the n, and the $50 payment, we have 50 times 1 plus 0.00025 to the 1,560th power minus 1 divided by 0.00025. And doing them one at a time, order of operations. I'm going to do that 1 plus 0.00025 to the 1,560th power. And I'm going to get 1.4769088805. I need to subtract 1 from that and divide by the I again. When I subtract 1, I get 0.4769088805 divided by 0.000025. Or 1,907.635219. Remember way back when I said that this number should be more than the number of compounding periods? We had 1,560 compounding periods, and we've got 1,907 as our number here. So that sort of serves as a little back check for me. I know whatever this number it's supposed to be more than the number of compounding periods. Because if it's not, then Steve's not making any money. When I multiply this out, we see that we've got $95,381 and rounded to the nearest cent, 76 cents. So Steve has put away $50 a year over 30 years. And in the end, he has almost $100,000, $95,381.76. how much is Steve actually invested and how much of this is interest, right? So Steve has put away $50 every week for 30 years. That means Steve has invested a total of $78,000. So Steve has invested in total $78,000 of his hard-earned cash. He was able to take out of this account $95,381.76. So Steve made a little bit extra here. That extra is the interest. So to find the interest, we're going to take that future value of $95,381.76, and we're going to subtract the $7,800 that Steve put in with his own hard-earned money, and we get $17,381.76 in interest. I cannot encourage you enough. Please take some time and practice with your calculator, because that's going to be the one thing. You get all of these bit parts. It's working on this calculator that is going to be the one thing that could sort of sink you under. So let's go through a couple of those. This is, again, a practice table. You can click through this on your own in the PowerPoint provided, but I'm also going to click through it here. I'll explain the first one and see what we do. So we've got a payment of $280 for 5 years. It's going to be at 3.6% interest compounded monthly. That means that our payments are going to be made monthly and the compounds are going to be made monthly. Our I value then would be 0.036 divided by 12, or 0.003. Our N would be the 5 years times 12 times a year, or 60. This means that the future value would put 280 in the payments, 0.003 in the I value, and 60 as our N. Or 280 times, square brackets, 1 plus 0.003 to the 60th power minus 1. Divide all of that by 0.003. And when you work that out in your calculator, you got more than 20,000 or less than 20,000. You should have $18,376.85. Second row says an $850 payment for 10 years at 2.4% compounded monthly. Again, that's putting away $850 a month, and the interest is being compounded monthly. Those have to match because these are ordinary annuities. So we've got an I value of 0.024 divided by 12, or 0.002. Monthly for 10 years gets us 120 compounds. Our payment, the amount being invested each month, is $850. So the formula should look like 850 times 1 plus 0.002 to the 120th power minus 1 over 0.002. Now, do you have more than $100,000? Is the future value of this account more than $100,000 or less? This time you should get $115,151.41. Skipping through the next two. Now, the only thing I want to say about this last one is notice that the 7% compounded weekly did not turn out to be a nice number. If you take 0.07 and you divide it by 52 weeks in a year, you do not get a clean number like 0.003 or 0.002 or 0.012. You get a big ugly decimal. So oftentimes people will do one of two things. They will just use 0.07 over 52 every time they need that calculation, or they will store that number 0.07 divided by 52. They will store 0.001346154 in their calculator. So that's the other option, is to store that in your calculator and then just do a recall when you need it. If you need help with that particular part of it, don't be afraid to contact somebody, right? The summary for the future value of an ordinary annuity. It has to be deposited at the end of those periods. It's equal amounts each time, same amount each time. The time is consistent. That is to say, it's every 4 weeks, it's every month, it's every year. And that you don't earn interest. Interest cannot be earned in the first period because you're depositing at the end. So because you're depositing at the end, there's zero in the account the whole first period, right? Common things that are ordinary annuities: loans, bonds. The table factor for an ordinary annuity is the cross section of I and N. In order to find the future value, you need the payment amount to be known, and you're going to multiply that by your table factor. The formula, once again, is the payment times square brackets 1 plus I to the nth power minus 1 divided by your I. I was going to say 0.002, but whatever your I value is. All right. Can you identify an ordinary annuity? Do you know the markers to identify an ordinary annuity? Can you follow the manual explanation? And did it help you understand? Can you use the future value table to calculate the future value of an annuity? Interest rate per period, the compounding periods, and identify the payment amount. Can you use the future value formula of an ordinary annuity to calculate it? Can you substitute in and identify the correct parts of the formula using that calculator to get an answer? Are you able to separate out the amount of the investment, the interest earned, and the future value? So can you use the future value and the amount originally invested to find the interest that was earned on that annuity? Okay. In your eText, this is chapter 12, section 1. There are review exercises at the end of that. Because we're only doing the ordinary annuities, I recommend you keep your review exercises to problems 1 through 5, 11, 13, 16 through 18, 22, and 24. This extra practice is also available in your physical textbook. I believe those pages are 377 to 379. As hopefully you expected, there is also a graded assignment. That assignment is on WebAssign. It is so creatively titled Chapter 12, Section 1, and I did my best to limit to those problems that are germane to this particular presentation. If you find one that's not, shoot me an email. All right? As always, if you run into trouble, contact myself, your embedded math support, or the Math Center for help. We are all here to see you do well. This is just the last few weeks. Just push through. You got this. We will help.